Whoops. Hi, everybody. So this is the next video for pre-algebra, 8.4, the slope of a line. So I'm going to separate the rest of the videos now, and I'm going to do each video individually for the rest of the lessons. So I'm going to discuss the slope of a line. So when you have a line that has any type of tilt or slope to it, you have a certain distance in the x direction, and then you have a certain distance in the y direction. When you refer to slope, slope is referred to as m for whatever reason. And then the slope is represented as the y in your numerator over the x. So if you have a line itself on a graph, you can count how much in the y direction and how much in the x, set it up as a fraction, and you'll get the slope. That's the first method. When you have actual ordered pairs given to you, and they don't give you the graph, you have to use the formula. And the formula is y2 minus y1 over x2 minus x1, which I'm going to discuss in the first examples. When you're looking at the lines themselves, any line this way in that direction is positive. Any line this way is negative. A vertical line is undefined, and a horizontal line has a zero slope. So a line, and here we have slope guy, makes a face. This direction is a positive slope. This direction is a negative slope. A straight line going up and down, a vertical line, is undefined, and a horizontal line like this has a zero slope. So here we have our first example. So I'm going to teach you both methods. When you have a graph given to you, you can either count or you can solve for it algebraically using the formula. We're going to do both. So if we're going to count, then we're going to set up our fraction, which is our y. That did not come out. Our y over the x, known to as rise over run. So going from one point to the other, I always like to move in the y direction first because that's what goes in our numerator. So going from here to here, or you could go from here to here, it doesn't really matter. I'm going to go down a certain amount. Well, I'm going to focus on my y's only. So if I notice I'm at 5 and I have to get to 2, so that means I'm going to go down 1, 2, 3. Down, I went down 3. So that means negative. I'm going to start plugging into my fraction. So for the y direction, I went down 3. From there, I'm going to move to the left. 1, 2. And I went from 4 to 1. I'm here. Oops, I went 3. 1, 2, 3. I said 2, but it's not. It's 3. I went to the left. Left being negative 3, which comes out to be just 1. 3 over 3 and a negative is a positive 1. So if you're looking at the graph itself, you can count the points and make sure you keep track of the direction. If you don't keep track of the direction, you could just count how many y's, how many x's, and then refer back to our slope guy. A line going in this direction is positive, which it is. A line going in this direction is negative. Well, we counted, but we want to confirm that we got the correct slope. And you can use both methods when they give you the graph itself. So we have our two ordered pairs. I'm going to do it over here. 4, 5, and 1, 2. Now we're going to use the slope formula to solve for our slope. So our slope formula is y2 minus y1 over x2 minus x1. So I'm going to take you pick which one you want to be 1 and which one you want to be 2, and it does not matter the order. So let's say I want to make this one 1. That means this is x1, y1. This one's going to be number 2, x2, y2. So now you have to make sure that you plug it in correctly. Number 1, you got to make sure that your y values are in the numerator and that you're following the order of the values themselves. So I'm going to plug in y2 first. 5 minus, because of the formula, and then y1, which is 2. Then we're going to plug in x2. x2 is 4 minus, because of the formula, x1. And then we simplify. 5 minus 2 is 3. 4 minus 1 is 3, which comes out to be 1. Same as here. So the slope of this line is equal to 1. That's the first one. We're going to do one more. Another color. Let's see how this comes out. So here we have another line. We want to determine the slope. We're going to use both methods. We're going to count, which is our y over the x, our rise over run. So I'm going to go from this point to this point. So from here, I'm going to move, always move in the y direction first. It makes it so much easier. I'm going to go up. 1, 2, 3, 4. I was off a little bit. So I went up 3. Now from there, I'm going to go to the left. 1, 2, 3. Did I count wrong? I think it's more. It's 4. Because we're at -3. So we went up 1, 2, 3, 4. I'm like, what is it with me counting today? I'm not counting right. +4. Don't do that mistake. So counting, I counted 4 up, so it's a +4, and then to the left, 3. So y direction goes on top, so +4 over -3. It's already simplified, so -4/3. This is the same as this, which is the same as this. Doesn't matter where you put the negative. It could be in the numerator, right in front of the fraction, or in the denominator. They're all equivalent. Well, now we're going to take the two ordered pairs and solve it algebraically. We have 0, 1, and 3, -3. I'm going to plug it into our formula. y2 minus y1 over x2 minus x1. Choose a different color. So I always like to label my ordered pairs just to make sure. This is going to be my number 1, so x1, y1. This is going to be number 2, so x2, y2. So now we want to make sure that we plug it in correctly. y2 comes first, so 1 minus y1, which is a -3. That negative is there because of the formula. That negative is there because it's part of the value itself of the number. Now x2, which is 0, minus, because of the formula, x1. Well, a negative and a negative gives us a positive, so it actually ends up being 1 plus 4. 1 plus, oh my gosh, what's wrong with me today? 1 plus 3, I was giving the answer already. 1 plus 3, which is 4, over -3. So our slope is -4/3. I always like to apply my negatives to my numerator. So that is the second example using both methods. Don't do the same mistake I did twice. Now we're moving on to, that was example 1. Oh no, that was actually example 2. Sorry. So now we're moving on to example 3. Example 3 talks about the slopes of horizontal and vertical lines. So as we discussed before in the previous section, when you go to graph anything that has one variable, you end up with a horizontal or a vertical line. Well, that Hoy-Vux also helps us determine the slope. Whenever you have a horizontal line like we have right here, this is telling us it should have a 0 slope. So the m should be 0. We're going to use the formula to make sure that that is correct. More like to prove it. So m is equal to y2 minus y1 over x2 minus x1. I'm going to move it over here. So 1, 3 and 4, 3. This is number 1, x1, y1. This is number 2, x2, y2. Again, it doesn't matter which one you pick, but once you pick one to be 1, the subscripts have to be the same as number 2. If this is number 2, you can't mix and match. So now we're going to plug in our values. y2 minus y1 over x2 minus x1. Numerator comes out to be 0, -3. Well, whenever you get a 0 in the numerator, your answer is 0. So we proved that a horizontal line does have a 0 slope. Vertical line. Well, just like it says here in Vux, whenever you have a vertical line, your slope is undefined. So now we're going to prove it. Same formula. We're going to take our ordered pairs, 2, 3, 2, -1. Use blue again. And let's label. It's going to be number 1, so x1, y1. This is number 2, so x2, y2. And we're going to plug it into our slope formula. y2 is -1 minus y1, which is 3, over x2, which is 2, minus 2. Our numerator comes out to be -4. Same sign, you add and keep the sign. And our denominator comes out to be 0. Whenever you have 0 in your denominator, that's undefined. You cannot have a 0 in the denominator. So we just proved that our vertical line is undefined. My voice is getting a little crappy. Anyways, that is the end of 8.4. Make sure that you come back and watch for 8.5. Bye.